All right, so this is the second half, hopefully the whole half, of the calculator section on PARCC practice test part 2, starting with number 6. So we have a line, and the line has been used, line T that is, has been used to create 3 triangles, really. I mean, they call it 2, but really it kind of looks like 3. And so we have this triangle right here that may actually look like a triangle if I choose the pen, right here. And we'll recognize that here's my rise, here's my run. And then we have another triangle that they gave us right here. And we know that we could pick any 2 points on a line and create a triangle out of them, and we would get the same slope, regardless of which triangle we created. And so we could even use this triangle right here to get the slope of this thing. And so let's keep that in mind, and we're going to remember that slope, m, is going to be rise over run. All right, so the slope of AC is equal to the slope of BD. Well, AC and BD, well, yeah, they're on the same line. Of course they will. The slope of AC is equal to the slope of BD. AC, B, yes, that is clearly the case. The slope of AC is equal to the slope of line T. They're all on the same line. The answer is yes. The slope of T is equal to EC over AE. They tried to trick you here. EC is the run. And we know that slope is rise over run. They switched it, didn't they? That is not correct. The slope of T is equal to FB over FD. So FB, well, that is a rise because it's going up and down. FD, we've got it. So we know that's right. The slope of line T is AE over F. No, because now we're using 2 different triangles. We have to use just one rise and one run from the same triangle to get the slope. So that's why that one is not correct. All right. Number 7. All right. The pool cleaning service drained a full pool. The table shows the number of hours it drained and the amount of water remaining in the pool at that time. Great. Plot the points to show the relationship between the number of hours elapsed and the number of gallons left in the pool. Select a place on the grid to plot each point. All right. So we have 3, and we notice that the scale on the x-axis is counting by 1. That's going to be helpful. So we have 3, 13,200. So 1, 2, 3, and we have 13,200. Well, 13,200 is going to be less than 13,600 and more than 12,000. And how much more? Well, the difference between the two is 8, half of 8. Oh, it's going to be right in the middle, isn't it? So I'm going to go ahead and put my point here. Now how? So notice how I can only put dots at grid points or in between, in the middle of 2 grid points. So I don't have to worry about where in there it goes. I know it's just in between there. So then we have 5 and 12,000. So 4, 5, 12,000. 7, 10,800. So 10,800 is going to be in between these 2 lines, and that was 5, 6, 7. And then 9,600. And then 11, 8,400. So I go to 11 and 8,400, which is going to be right there. And so I've successfully plotted all the points. Oh, part B. The data suggests a linear relationship between the number of hours the pool had been draining and the number of gallons draining the pool. Assume the relationship is linear. What does the rate of change, that's the slope, what does the rate of change represent in the context of this relationship? Well, the rate of change, well, what's changing in the pool? We're losing water. So the rate of change reflects the loss of water. And to be more accurate, the rate of change shows exactly how much the pool is losing in 1 hour. So let's look at A. It says the number of gallons of water in the pool after 1 hour. So we want the number of gallons that have been drained from the pool in an hour. B says the number of hours it took to drain the number of gallons drained each hour. That's what we're looking at. C. And a D. Oh, you gotta be kidding me. What does the y-intercept of the linear function represent in the context of this relationship? Well, notice how we are losing water, right? So that means the y-intercept is going to reflect how much water was in the pool to start with. So the number of gallons of water in the pool when it was full. And that's what we started with, full pool. Which equation describes the relationship? Okay, so now we need the slope and the y-intercept. So if I go up here, I can clearly see that my y-intercept, if I follow this line, I'm clearly going to be between 1440 and 15.2. That gives me a hint. But we don't want a hint. We want to get it for sure. So I'm going to get all the way up here. And I was going to go down and use process elimination, but I think this is probably a better idea. So I'm going to find my rise, which is the change in my change in my y, sorry, and my run, which is the change in my x. And so from here to here, I lost 1,800 gallons. No, is that right? No, I lost 1,200 gallons. And I again lost the same amount here, 1,200 gallons. And that is being drained every 2 hours. So that means in 1 hour, I will drain 600 gallons. Well, that means in 3 hours, and why 3 hours? Because 3 hours here, I will have drained 1,800 gallons from that pool. Well, so if I put those back after 3 hours and add that to my 13,200, and the reason why I'm adding is I'm going back in time, carry the 1, 3 plus 1 plus 1. So that's 15,000 gallons to begin with. So I have a slope of negative 600. Come on, anytime. Negative 600, and I start at 15. And we could use the process of elimination because only one slope makes sense, which is this 15,000. And we know we're not losing 1,200 gallons per hour. We're losing that in every 2 hours. They're trying to trick you. All right. Number 8. Two different proportional relationships is just a linear relationship with a y-intercept of 0. All right. So we have a slope here of 9 and a slope of, I don't know here. So let's figure this out, shall we? We have a rise of 3, sorry, a run of 3, and a rise of 34.5. And so let's go ahead and divide this out. Well, I should probably read the directions first. Use the drop-down menu to complete the sentence comparing the rates of change for the, so we have to find the rates of change, the slope. And this is going to be greater than or less than, I'm willing to bet. Boop. Oh. Oh, so we're relating the two. Okay, so we still need to know it. And we know the rate of change over here is going to be 9. All right, so 34.5 divided by 3. Well, 3 goes in 3 once. 3 goes into 4 once with a remainder of 1. And 3 goes into 15 5 times. So we have a rate of change of 11.5. So the rate of change for proportion A is, and now I have to clear this so I can actually hit the button, 2.5 less than the rate of change in proportion B, because 9 is 2.5 less than 11.5. Back half had some shorter questions. It's nice. All right, number 9. 2 parts. Eric planted a seedling in his garden and recorded its height each week. The equations shown can be used to estimate the height, h, in inches of the seedling by the end of each week, w, after it was planted. So we have a linear relationship where the slope is 3/4 and the y-intercept, and in this case, how high it was, or how tall it was when it was planted, is 9/4. What does the slope of the graph, the equation, represent? Well, it shows how much it is growing each week, because we're multiplying 3/4 by each week. So let's look at A. The height in inches of the seedling after W weeks. No. We want the height in inches of the seedling after W. Actually, wait a second. Okay, so the height in inches of the seedling when Eric first planted it, that's the 9/4, definitely not it. The increase in the height of the seedling each week. Yes, because it is increasing by 3/4 each week, so that's clearly it. All right. Estimate the height of the seedling. The seedling is now 8.2 inches after how many weeks? Okay, so is 8.25 a W or an H? It's a H, right? Because it's the height. So we have 8.25 is equal to 0.75 W plus 2.25. All right, and so I'm allowed to use my calculator, so I'll pull it up. All right, so the first thing I'm going to do is I'm going to subtract 2.25 from both sides, and I will get 6 is equal to 0.75 W. So now 6 divided by 0.75, so it's about 8 weeks. All right, let's go on to number 10. All right, function A, B, and C are linear functions. Some values of function A are shown in the table. Great. The graph of function B has a y-intercept of 3 and a x-intercept of -5. C as defined by the equation. Okay. So, all right. So let's start with the easiest. The rate of change again is slope. The slope for C is 3. So here we need to find our slope, and has an x-intercept, let me change colors, has an x-intercept of -5 and a y-intercept of 3. So that means I went up 3, I went over 5, and it's moving in a positive direction. So B has a slope of 3/5, positive 3/5. Now let's look at A. Here's my rise, here's my run. I have a rise of 4 and a run of 2, therefore I have a slope of 4 divided by 2, which is 2. All right, So which has the smallest rate of change? Clearly function B. Which has the second one? 2 is smaller than 3, so there we go. So it should read B, A, and C. All right, that was quick and easy. Number 11. 2 parts. We love 2 parts. All right, the figure, I have a cylinder and a cone of the same height and radius. Sweet. And I know that the volume of a cone, of a cylinder, is the area of the base, which is pi r squared times the height. And the volume of the cone is going to be 1/3 the volume of the cylinder. Great. Okay. And we want the answer in terms of pi, which means we don't have to multiply out 3.14. So the radius is 4, so we have 4 squared times the height is 3, times pi. 4 squared is 16. 16 times 3 times pi. 16 times 3 is 48. So we have 48 pi. And that's D. But wait a second. We want the volume of the cone. This is the volume of the cylinder. So the volume of the cone is 1/3 of this. So if I divide 48 pi by 3, I will get a grand total of 16 pi. So the answer to B, or A, is B. Scroll down. All right. What is the ratio? Oh, when I say ratio, you think fraction. So the ratio of the cone's volume to the cylinder's volume is going to be, well, we have 16 pi over 48 pi, and we know that pi divided by pi is 1, and we have to reduce this fraction, so we get just 1/3. So we would have to go ahead and use this button right here, boop, for the fraction. And so we'll put in 1/3 for 1/3. All right, let's keep plugging on. 2 more to go. Let's get these 2. A solution is 20% bleach. Create a graph that represents all possible combinations of the number of liters of bleach contained in the liters of a solution. All right, so we have, great. So I know that I just need 2 points and I'll have my line really quick. And I know if I have 0 liters of solution, I will have 0 liters of bleach. Let's start with the easy ones, shall we? And then let's go with 10, because that's easy. If I have 10 liters of solution and 20%, well, 20% is 1/5. What's 1/5 of 10? 2. And there you go. It is that simple. Incidentally, you could have picked any point on this line and it would have been fine. So if I could get rid of that, it does not matter. All right, last problem. Oh, I love that calculator. The E, -7. That's just a way of giving you scientific notation, right? So really, this is saying 6 times 10 to the -7. Well, how do I convert this into standard notation? Well, I know it's going to be less than 1, but it's going to be greater than 0. This is a positive number. And so I'm going to take my 6.0. I'm going to move the decimal place 7 to the right, or sorry, to the left, because it needs to be smaller than 1. 1, 2, 3, 4, 5, 6, 7. I'm going to plug in my zeros. And so I have 1 Well, including the 0 in front of the decimal point, I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. So we know this is it. And so there we have it. The computer section, part 2, 8th grade part.